We're back on our dirt brown 1988 Suburban today, and the air conditioning doesn't work. Hasn't worked since we got it. We're gonna try to get it working. So, quick perusal of our air conditioning system. It's been converted to R134A. It is an orifice tube system, so look at that. And it's got O-ring seals throughout. It's a Harrison system, so it's got the R4 compressor. Don't know if that works or not. We're gonna find out. But it's all hooked up. Looks like we got a new belt on there. We got all new belts on here, so somebody had high hopes. Compressor's free, it does spin. That's a good start. So without further ado, we're just gonna randomly start tearing into stuff and see what happens. So the first thing to do with the AC system is I want to know what's in there right now. Is there pressure? We know the system doesn't engage or anything, but we don't know if that's electrical or anything. So the first thing I want to see is what's inside that system. We're going to hook up our gauge set. I guess we got to drain it first, don't we? Well, you're not prepared. I got no pressure there. I got no pressure there. So it's dead empty. So what we're going to do is vacuum it down, and obviously it probably has a leak somewhere, but to do that we got to see where the leak is. So the best way to do this is with nitrogen or so forth, but I don't have any of that. We're going to do it the cheap way, but we're going to vacuum it down, get all the air out, and we're going to put in a little bit of refrigerant, and then we're going to run a leak tester on it. So the way we vacuum this down is since it's empty, we can just vent this since it's just air we're pulling out. And just gonna vent it like that. Basically, that just it runs air past the venturi and creates a vacuum and pulls anything out of the system. And oh, you gotta open your gauge set here. And then you should see a vacuum. Should see it start to pull a vacuum on the gauges. It's not pulling a great vacuum. So I'm thinking we might have a big leak somewhere. Either that, sometimes it takes a while to kind of pull everything out and get that vacuum down. So I don't know, we're about down to 10 inches of mercury. She's still going down a little. I don't know, we'll see. See what we can pull here. And then the other thing, of course, is the bleed down test. So generally, I'll let it sit with a vacuum on it and the gauge is hooked up for a while and see what the leak down rate is, and if there's any, because if there's any, there shouldn't be any leak down. It should be vacuum tight. If there is a leak down, then obviously you got to find the leak and fix it. But I'm thinking vacuum is not going down very fast, so I'm thinking we probably have a big leak somewhere. That was to be expected, but these old systems that sit a while, the O-rings go bad, and if they have O-rings and not flare fittings, the O-rings can wear and that sort of thing. Not many automotive systems use flare fittings. Our work truck does, because that's an aftermarket system. But the O-rings and everything are the cheaper way to go, so that's the way the manufacturers do it. Obviously, the best air conditioning joint is a solder joint, but you know, you got to have some flexibility in cars, so you got to end up with rubber hoses and joints and so forth. Yeah, she's only going down to 10 here. Well, let's shut it down and see if it'll hold 10. She is kind of holding 10. I guess we can shoot a little bit of refrigerant in there and then run our leak tester over it. Yeah, she's got a very slow bleed. Alright, well, now we got a vacuum on it. Let's leak test it. Sorry for the noise in the background. I have to run my air compressor to run that vacuum, obviously, but it's not quiet. That valve, bleed off any air in here. Alright, get my leak tester and go over this. If you've never used one of these before, the way this works is it senses the refrigerant molecules. And you'll hear that whooping. Needs recalibrated. Let's hit the reset button. Unless we do have a really big leak somewhere. Alright, let's see. We got a little bit of leak from that fitting. These quick connect fittings aren't exactly perfect, so. Uh-oh. The sender's leaking there. Get the hit on that joint too. Getting a lot of hits. You might end up stripping this down and we're getting a hit on that. So all the seals are leaking. About on the compressor. The compressor appears good, but we'll probably replace them anyway. Maybe not. Turn off for me now. Okay, so since we have refrigerant in here, what we're going to do is see if we can fire it up even though it is leaking, and we'll make sure everything works and see how well it works. The main thing we want to know is, does the compressor work? So shut off our high side there. Don't run it with the high side open. Not just bad things happen. Alright, well, we got about 65 psi in there. Oh, compressor short cycling. That's a good sign. She's working anyway. See if we can suck in some juice there with the cycling. We are getting a little bit of pressure build up each time the compressor cycles, so that's good. It's starting to suck it in. I'm not going to worry about exact charge on this right now because I'm probably just going to end up sucking this out again anyway to replace all the seals. So we'll just continue with the testing. Compressor is a little noisy, but these Harrison R4s are, well, they're pretty noisy anyway. So I put my thermometer inside the cabin. We're just going to test this. And obviously the compressor is short cycling, so it's only sucking in a little bit at a time, and it's not actually enough to draw this down significantly. So since we know there's refrigerant in it, because we have it hooked up and the valve's open, we're going to short out the low pressure switch so it can run continuously. The way you do that is you just unhook it here, and unhooking it will disconnect the compressor, but then we're going to take a jumper wire and we're going to continuously short out the switch. That'll make the compressor run continuously. Make sure you watch your gauges when you do this. It should be building pressure. If it doesn't, then disconnect it. But we're staying at about 125. It's got to suck in a lot of juice here because it was completely empty. Give it a break here for a minute. See what our low point is. Sometimes you can build more suction if you let it go down lower and then restart it again and let it shoot up. Sometimes, I don't know. It varies with compressors. You just never know. And we didn't suck in a lot yet. One thing you can do with these systems, because this is an orifice tube system, it has an accumulator. So you can add liquid, because you won't slug the compressor. What I'm doing now is I'm getting my bottle higher than the gauge set and everything, and so the liquid is actually, I don't know if you can see the sight glass there, but the liquid is actually going right from the can, rather than instead of relying on gas evaporating up through the system, we're running liquid down into the system. And basically we're just going to charge it by pressures right now, and we're going to see what we can get up to, and we're going to see what temperature we can make with it and see if the system's working. If the orifice tube is clogged or something, then it's not going to make very good pressure, but we will see. Don't charge a metering valve system this way because you can slug the compressor really easy. But you can see the low side port feeds right into the accumulator, so we're just filling the accumulator up with liquid. It's slowly building some pressure on the high side as it sucks in refrigerant, so that's good. We should probably add a little bit of oil because I don't know how dry the system is, but when we take it apart with the seals and everything, we'll add oil. I don't really want to add it and then suck it out and then add it again. It just, you know, contaminates everything. And all right, so I don't know if you can see it, but we got some frost down here by the orifice tube. I got frost up here by this, probably because that's liquid going right in there. So as soon as it goes into the accumulator, it's evaporating it. Well, hopefully. But let's check what our temperature is inside. That hasn't brought the temperature down yet, but that's not surprising because we're maybe at 130 psi on the high side. But you can tell it's making frost and everything, so we know the compressor works. It may not be completely healthy, but it works. Oh, one thing you got to check with these compressors when they're running is you got to check the nose seal. I didn't check that yet. Are slowly building pressure there, but I'm going to give the compressor a break because I didn't fully charge it with the right charge and oil and everything. So I'm going to shut this off and I'm going to leak test it again just to verify. I'm going to check the nose of the compressor here. There's a seal. It's kind of hard to leak test it because it's back behind the pulley. But you can kind of stick the nose of your gun down and around there, and refrigerant falls. R134A anyway, it falls. So you want to test below the seal. I'm not getting any hits there, that's good. See if we're still getting our hits on the, yep, we're getting a hit there. And definitely on our sensor there. Getting a little bit of one there, yeah, so definitely, and you can, we got to replace those seals, but and you can kind of go over your condenser and evaporator just to check for spots of refrigerant leaking out. Not getting anything on that. Of course, on this it's hard to check the evaporator because it's down in that box there. Sometimes the way I test the evaporators on these square bodies is I'll take away this seal material and then I can get my probe down in there and kind of, you know, snake it around on this side of the evaporator, and you can test them that way without ripping it all apart. But I'm not going to worry about that unless we have a massive leak. Once we get all these buttoned up, if we still have a leak, then we'll check the evaporator and we'll check the condenser a little better if we still have a leak then. But looks like we need to replace seals. Normally when I do one of these jobs, I replace the accumulator dryer because there's a dryer in there. There's a desiccant pack, and it will suck, basically kind of absorb the air, oxygen, and, you know, any gas that's not refrigerant out of the... We're gonna have to replace the Schrader valve in this because I don't know if you can hear that, but he's leaking right out through the valve. But we've got replacement valves, so there's probably that leak, part of that leak there, but That's part of this too. Replace as much of the consumables as you can, like the Schrader valves and O-rings and anything that wears over time. Here's like our switch is okay, and we know that it works because it cycles the compressor on and off. So probably just going to replace this O-ring here. And there's O-rings here, and there's O-rings here into the condenser, and then down here there's a Schrader valve and another O-ring. And then over on the compressor side there's O-rings in the back of that, but that doesn't appear to be leaking. We might leave that. They're generally more specialized O-rings. They have like a metal outside with a rubber inside, and I don't think I carry those, but we'll see. Probably just try to get away with not replacing them. Oh, tear this down. Do I have the right wrenches? Yes, I do. Well, that never happens. You don't have to tighten these a lot because the O-ring is the seal, not the threads or anything. So you don't have to over tighten them when you do this. Yeah, just a note. Don't have to crank them down like Hercules. That refrigerant. Hope the EPA isn't watching. Thought she had mostly leaked down unintentionally, but I guess not. Gotta watch it when you have refrigerant, a high charge of refrigerant leaking out like that. You can freeze your fingers pretty quick if you get in the path of it, because it's evaporating and creating cold air. So if you have a refrigerant leak, don't hold your hand in front of it. And if you have to, certainly don't do it very long, because you're at risk if you do that. Oh, these fittings came off really good. Take these out. Oh, I've got to loosen that up so we don't break something. Well, you don't need to watch me replace O-rings. That's probably boring. So we're going to replace these O-rings, this Schrader valve, that Schrader valve, this O-ring, and the two on the condenser. And then we will, I think, leak test it again. So we'll get back to you when we have those parts replaced. So we're about midway through O-ring and seal replacement. And one thing I forgot to mention is the orfice tube, which this system has. And if you're not familiar with it, it goes right into the evaporator right there, the entrance to the evaporator. And as I was taking these apart, I noticed some black goop, which is indicative of deteriorating O-rings, which we definitely saw some deteriorated O-rings. We're going to vacuum the system down really good, and here's why. It really ought to be flushed with nitrogen or something, but I'm not going to do that. It's old, and I'm not really going to replace any parts. So here's the orfice tube. If you notice the gunk buildup on there, now that can happen with O-ring deterioration, and it can also happen when you convert a system from R12 to R134A and do not use the proper chemicals, because R12 usually uses mineral oil, or at least used mineral oil back in the day, and the new R134A systems use PAG or ester oil, usually a synthetic of some kind. Anyway, they don't work well together if you don't completely drain the system, and if you don't use the correct chemicals in the kits to convert them over. You can get sludge buildup like this. You can get deteriorated O-rings. You can get all kinds of problems. It can sludge up your compressor and all kinds of things. It looks like in this case the screen on the orfice tube seems to have caught it, because the actual exit end, there's some oil there, but it's not really sludged up. So I think we caught it in time. Not quite done yet. We have a few more O-rings to replace, and Schrader valves. We pulled the Schrader valves as well. Where did I put them here? Those are also very sludged up. Yeah, there's some serious gunk there. Where to put the other one? Oh, here it fell on the ground. This one actually has lots of green gunk and something like somebody tried to put some of that leak seal or something in there. It's not great, but this is the one that was leaking from here. We ended up putting a new fitting on because what they did when they converted it over was the R12 fitting has a Schrader valve, and then they put on a new one with a second valve. So the first valve pushes the second valve. Well, two valves in a row, just more moving parts, things to go bad. So we pulled that fitting off and we put on a new fitting with just one valve. But yeah, the Schrader valves are just cooked. And well, that one actually has some deteriorated rubber. Not good. Anyway, we're going to try to vacuum and clean the system really good when we put it back together. The clogging on this orifice tube could also be why there was too much frosting on the evaporator entry too. You know, it just changes your orifice and everything. So we're gonna fix that. We're gonna put some of these, we got this seal to replace here, and put this line back in that we replaced the Schrader valve on, and replaced the O-rings, and just blew it out since we had it off the vehicle, and we'll put her back together and vacuum it down. Oh, new orifice tube. That's what they're supposed to look like. Oh, where'd you go now? I really pack these things in there. That's what they ought to look like. You got your filter screen here, and of course your exit screen. This is mostly for debris and that kind of thing, and you can actually see the orifice pin in this one, so that's a good thing. Take our cap out of there. Make sure we get it in the right way. Push it until it's seated. And then we can button this up and finish our O-ring replacement. Here's some of this black gunk I'm talking about with the deteriorating O-rings. That's what you get there. And unfortunately it coats a lot of the inside of the system and everything. Like I said, this really ought to be cleaned a lot better than I'm going to clean it if you wanted it to work like brand new. But, and the compressor isn't brand new on this either, so you know, it's one of those things that at some point you just gotta decide where to save money. And oh, that one's too big. I'll put the right O-ring on. Like that one's too small. I don't know. You gotta make sure you get the right O-rings in these, because that is your whole seal. No threads or anything, it's just the O-ring. And if you don't have the O-ring the right size, and if it doesn't seat properly, you're always going to have a leak. You know, and we're talking refrigerant, so even a small leak at the molecule level will just result in non-sealing. I think that's about perfect there. All right. So tighten that up. I'll put that line back on, or put it out of the way so I wouldn't mess it up. And then I believe we are ready to put in some oil and refrigerant, and maybe take her up to full pressure. And I believe this thing should have a tag on it somewhere. Well, 3 1/4 pounds of R12. We can convert that. There's a conversion for our 134A, I think. I have to get up my calculator or something. I don't know. I got to look that up, and we can either put in the proper charge, or we can charge it by gauge levels. Most of the time, I just charge it by gauge pressure readings, high and low, and how the temperature is coming out. But that's not as precise. If you put in the exact charge for the system, you know it's right. You don't have to guess, but Again, this is originally an R12 system, so the R134A charge is going to be different. So let's get our button back up here. All right, we got our button back up. Got our gauge set hooked up. We're going to vacuum it down again before we recharge it. Are we pulling a better vacuum than before? I don't know. 10 inches of mercury. It went up to 10 pretty quick, but going any higher? A little bit. She's creeping up. I like to see at least 20 or better, but we might still have a leak somewhere. She's maybe doing a little better than 10. We're going to vacuum this down for, well, probably at least half an hour or so, or till our air compressor explodes. So we put in our liquid refrigerant charge, and we're going to wait because that's liquid, and we put liquid in, you know, the high and the low side. So we want to make sure that that liquid is all evaporated so we don't slug the compressor. We do have the accumulator on this, so, you know, in theory it should protect it, but just want to be certain. I don't want to risk it. This compressor is probably a little older and weaker than normal anyway, so I'm gonna wait a couple of minutes here to let that kind of distribute and equalize throughout the system. All right, we've let everything equalize a little bit here. I'm gonna start her up and then go around with the leak tester. Probably won't put a full charge in it until I'm sure that the O-rings are okay. So then you just gotta remove the charge again. So start her up. Still getting a hit on that sensor. And a little bit of a hit on the lower condenser line. I think we're just getting a hit off of this quick connect fitting here, but 150 psi. Oh, there, now we're going up. 160 psi. Be careful, I don't want to overcharge it. I'll shut this down for a minute and static leak test it. As you get air moving around when the engine's running, and it can give you a false positive. A little hit there. So just give that fitting another turn. Definitely a hit from that pressure switch. Bit there, could be leaking from the fitting. Oh no, come on. Gotta reset you. I don't think we have a leak there. I think it was just picking up residual from the quick connect fitting. I think it's the same thing there, residual from the connector. I'm not getting it now. Just to be sure. Reset it. Oh, maybe. We'll tighten that connection just to be sure. Oh, no. Come on now. Be careful with false positives on this, on these testers. That Schrader valve could be leaking. I'll have to check that. I'm not getting anything from the sensor. Let me get my wrenches and tighten some of these fittings up, and I'll go for round 2. Okay, we double checked all our fitting tightnesses. I did replace the pressure switch. The old one, I don't know, it could be a little gummed up. I'm not sure. We're gonna find out, because I just, you know, happen to carry these things. I think it even has roughly the same pressure rating, but it's a minimum cutoff, so as long as it, you know, is within a range, it'll work. So I think we're ready to start her up and give her another test here. Maybe give it a full charge, I don't know. Let her suck in some refrigerant here. If we can get it past the short cycling point, then maybe we can see if it makes cold air. Let's see what temperature air we're getting in the cabin. It's starting to cool the cabin down a little bit. Just a little. Sometimes these take a while to suck in a charge this way. I only put in, you know, a little bit of liquid, probably less than a pound, because I was too lazy to look up the exact specs, but we're going to charge her by gauges right now. Oh, it's got good suction. Still a little low. I'd have to tighten up that AC belt. She's whipping around a little. It needs a little bit more tension. Cabin temperature is starting to go down. That's good. About 185 psi on the high side. Cut off our gas here for a minute. Pulls it down to 25, so probably still a little low. We're up to 190 on the high side. I'm surprised this is working so well, being as old as it is and probably abused. Compressor is still a little bit noisy, but those Harrison R4 units, they kind of make that clickety-clack. There's just no way around that. Even brand new. Yeah, we're up to 200 psi. Anyway, what I was saying was, because it's hotter in Donut Grease at a Fat Man's convention out today, we're probably looking for about 250 on the high side and somewhere between 40 and 50 on the low side. Because the ambient was like, you know, 363 degrees today. Just kidding. But it is over 100, I think. 205. Let's see if our switch works yet. And now our switch is working. We're up to 210 on the high side. And about 36 on the low side. Generally, the higher the ambient temperature, the higher your pressure readings need to be. You know, it's physics and all that. Math and stuff that I don't do. Where are we up to? 25, almost 235 on the high side, but we're only up to about 42 on the low, so we got some pressure to go yet. Looks like the low side pressure cutoff is about 30-ish. Usually they're written on the switch. Let's see. 3.1 kilograms per centimeter squared. I don't know what that converts to pounds. We don't use the metric system. Off at 1.7 kilograms per centimeter squared. I don't know. Guess I should check and see what we're getting out of the vents, huh? We're getting nice cold air in the cabin. And I'd like it to be 250 or higher on the high side. That's what a healthy system would probably be doing in this kind of temperature. I mean, ideally it would be probably 275, but for this system, I'd be happy with it up above 250. Did she make 250? Almost. Almost. She's getting there. Come on, baby. You can do it. Let's see where we're at on the low side. She's almost at 250. She's at like 248. You know, just replacing the seals and firing it up. I'm quite happy with that. Oh, no, she's hitting 250. 250 on the high side and 47, 48 on the low side. I'm pretty happy with that. The question is, will she leak down as we drive it and let it sit? I don't think so. The hit on the switch is gone. I think this switch, leaks a little bit. We'll probably get rid of that. I think we're just getting a hit around the high port down there, but I think that's the quick connect fitting. It's, you know, they're not the best seal in the whole world for high pressures like this. So I think we're gonna call that good. That'll do it for the air conditioning system on this old Suburban. If you liked what we're doing here, feel free to subscribe or like or comment. Doesn't cost you anything. It's free. And it helps us. Lets me know if I'm doing a good job or not. So hopefully we'll see you next time.